Right. Hi everyone. In this video, we are going to discuss about nodal analysis. Right? The main objective of nodal analysis is to determine the node voltages at various nodes of an electrical network. This method is based on Kirchhoff's current law and Ohm's law. Again, I repeat, this method is based on Kirchhoff's current law and Ohm's law. Right? So, let us see the definition of node. Let us see the definition of node. Node is defined as interconnection of two or more elements. Node is defined as interconnection of two or more elements. Right? These nodes are classified into two types. First type is simple node. Second one is principal node. Right? First one is simple node, second one is principal node. So let us see the simple node. Simple node means interconnection of two elements. Simple node means interconnection of two elements. I'll see the C. So let's consider a single resistor. Consider another resistor. Okay. Now see here. Interconnection of, that means these two are connected and to form a junction point. So this is the node. So interconnection of two elements. Interconnection of two elements is nothing but simple node. Okay. Next classification is principal node. Interconnection of more than two elements. Interconnection of more than two elements is nothing but principal node. Okay. I'll show you that network C. So here how many elements are there? More than two elements. That means three elements are there. Right. I'll show you another example. This is one example. I'll show you another example. Right. So here three resistors, one inductor. So more than two elements. So here four elements are there. So while solving the problems, always we prefer principal node. Please remember, always we prefer principal node. While solving problems, always we prefer principal node. Right? Please keep this point in your mind. Right? Now, so another important thing is, now here. In this method, in nodal analysis method, one node is assumed as a reference node. Right? In this method, one node as a reference node and its potential is assumed to be 0. That means one node should be grounded. For example, in a given electrical network, for example, let us see, let us take one example. I'll show you one example. So let us consider simple network. For example, this is resistor. This one is another resistor. Right? Now close the circuit. Connect a few more elements. For example, like this. Okay, this is simple network. So see here how many nodes are there. So this is one node. And always we prefer principal node. This is another node. Two nodes are there. So in nodal analysis method, one node is assumed as reference node. Our assumption is one node should be grounded. Simple. That means here two nodes are there. This one is first node. This one is second node. So right, from these two nodes, now select one node as reference node. Simple. Right. So here now I opt node 2 as reference node. What that means here, what is the meaning for this? Here, this node voltage should be 0. That means this node should be grounded. This node should be grounded. This is 0. Simple. Voltage is equal to 0. Right? So this is the explanation for that point. So what is the point? In this method, in node analysis method, one node is assumed as a reference node. And its potential is assumed to be 0. Right? Now see. Can I repeat all the points? I'll show you those points. So node definition is interconnection of two or more elements is called node. Nodes are classified into two types. First one is simple node. Second one is principal node. Simple node means interconnection of two elements. Principal node means interconnection of more than two elements. Right? So this method is based on Kirchhoff's current law and Ohm's law. Okay. So in this method, one node is assumed as a reference node and its potential is assumed to be 0. Okay. Now, very important point. Main objective of this method is, this node analysis method is to determine the node voltages at various nodes of the given network. That is the main objective. Okay. Let us see the procedure of nodal analysis. Right. By using this procedure, we have to calculate the current as well as voltage of the given network. Okay. Right. Let us see the procedure of nodal analysis. See. So here step 1. In this, step 1 is identify the number of nodes in a given electrical network. Identify the number of nodes in a given electrical network. That is step 1. Of course, I'll explain these steps through numerical. Okay, a little bit later I'll explain each and everything in detail. Okay, through numerical I'll explain each and everything. Right. So step 1 is identify the number of nodes in a given electrical network. That is step 1. Step 2, right? So from the identified nodes, select one node as reference node that should be grounded, right? Potential of that node is 0. Again, I repeat, from the identified nodes. So step 2, from the identified nodes, select one node as reference node and its potential is 0. Please remember, please keep this point in your mind, very important. In nodal analysis method, one node must be reference node. That is our assumption, right? Of course, one node as reference node. Okay, that should be grounded. Next, step number 3. Assign the variables to the nodes whose voltages are unknown. Again, I repeat. Assign the variables to the nodes, okay, whose voltages are unknown, like this. For example, in a given electric network, 3 nodes are there. Okay, one node should be grounded. Right? Now, how many nodes are there? 2 nodes. Now, assign the variables to the nodes whose voltages are unknown. That means here, now assign one variable. For example, now I'll assign for this node. This is first node, this is second node, right? I'll assign for this V1, right? That is the variable. For this V2, right? So these are unknown values, unknown voltages. V1, V2 are unknown voltages. Of course, I'll explain in detail through numerical, don't worry. Next one, step number 4. Apply KCL. Apply KCL at each of unknown node voltages. Just now we have discussed 3 nodes are there, for example. One node should be grounded, right? Here V1, here V2. Now apply KCL at first node. That is, after that, apply KCL at second node. Okay, apply KCL at first node, apply KCL at second node. Simple. So step number 5. Step number 5, solve the system of simultaneous equations which are obtained by the application of KCL at each of the node. Okay. So for example, here 2 nodes are there. That means 3 nodes are there. One node should be grounded. So now 2 nodes are there. Now apply KCL at this node. Apply KCL at this node. Right. Now after getting node equation 1, node equation 2, okay, we have to solve these 2 equations for getting node voltages. Right. For getting node voltages V1 and V2, we have to solve equation 1 and equation 2. Simple. Right. Let us see the numerical. So through that numerical, I'll explain each and every step. Okay, of nodal analysis. Very simple method. Right. So here I consider simple network. Now see. So your question is, so look at this. Here question is, determine the current flowing through 5 ohm resistor in the circuit below using nodal analysis. What is the question here? Determine the current passing through 5 ohm resistor. The current passing through 5 ohm resistor in the circuit below using nodal analysis. This is the circuit diagram. Okay, that means now this circuit diagram comprises of one voltage source, 4 resistors. One voltage source, 4 resistors. Okay, this is circuit diagram. Right. So we'll go step by step. I'll explain each and everything step by step. Now see, let us see the first step. Step number 1 of nodal analysis. What is step number 1? Identify the number of nodes in a given electrical network. That is step number 1. What is step 1? Identify the number of nodes in a given electrical network. Right. Now see that let us consider electrical network. This is the given electrical network. Now identify the number of nodes. How many nodes are there? What is the node here? Node means always we prefer principal nodes. Okay. So prefer principal node means principal node definition is interconnection of more than two elements. Interconnection of more than two elements. Now see here. So here 3 ohm resistor is one element, 2 ohm resistor is another element, 5 ohm resistor is third element. Now interconnection of these elements is nothing but node. That means always we prefer principal node, right? So this is the principal node. Simple. Okay. So here we don't consider, we don't prefer simple node. Always we prefer for solving problems, always we prefer principal node. Please keep this point in your mind. So here three elements are there. That's why this is one node. Okay. Now consider this. So due to network analysis, suddenly it has got disconnected. Okay. Anyway. Now see here. So here this is first node. Okay, interconnection of more than two elements. Now let us consider another node. This is second node. So here, so this is one element. This one is one element, right? So this is another element. This is third element. Interconnection of more than two elements is nothing but principal node, right? So here node 2. That is step number 1. What is step number 1? Identify the number of nodes in a given electrical network. So this is step 1. Okay. Let us see the step number 2. I'm explaining you very slowly. Right. Now here. Step number 2. So step number 2. What is step number 2 of nodal analysis? From the identified nodes, select one node as reference node. From the identified nodes, select one node as reference node. How many nodes are there? So how many nodes we have identified? 2 nodes we have identified. Right? So from those 2 nodes, one node as reference node. Right? Now I ought node 2 as reference. That means here this is reference node. And that potential is 0. So voltage is equal to 0. Right? And its potential is 0. So V equal to 0. That is step number 2. Very simple. Now step number 3. So let us see the step number 3. So what is step number 3? Assign variables to the nodes whose voltages are unknown. Assign variables to the nodes whose voltages are unknown. Right? That means here how many nodes are there? 2 nodes are there. So from those 2 nodes, one node should be grounded. So only one node is there. Now assign variable to that node whose value is unknown, whose voltage is unknown. Right? That means here, see, assign variables. Here V1 is the variable. Now assign V1 as variable at node 1. At node 2, 0. No need to consider node 2. The reason is VT equals 0. Okay. So here's assign variable. What is the variable here? V1 is the variable. Right? Now here. So another node is 0. Another, that means from those 2 nodes, one node should be grounded. One node must be reference node. Right? So this is step 3. Let us see the step number 4. Right. So step number 4 here. What is step number 4? Apply KCL at each of unknown node voltages. So here only one node is there. Okay. Now apply KCL at that node. Right. So another important thing here, this is my procedure. Please follow this procedure for any type of problem. Of course, number of techniques are there, but I request you people, please follow my procedure. Okay. So at this node, here my assumption is at this node, all currents are leaving. All currents are leaving. At this node, all currents are leaving. That is my assumption. Right? That means here at this node, my assumption is all currents are leaving means here how many paths are there? 3 paths are there. What is the first path here? This is first path. Now assume one current is passing through this. Second path is this one. And third path is this one. Okay. So there are 3 paths. That's why here I assume 3 currents. Okay. So I assume 3 currents. Those currents passing through 3 branches, 3 different branches. So those are I1, I2 and I3. Right. So here what is my assumption? All currents are leaving. Okay. I1, I2, I3. Okay, all are leaving, right? Now, what is the procedure here? What is the step number 4 here? Apply KCL at each of unknown node voltages. Okay, now apply KCL. Apply KCL at each of unknown node voltages. Right. So, what is the KCL equation here? What is the KCL statement? KCL states that sum of entering currents equal to sum of leaving currents at that node. Sum of currents entering into the node equal to sum of currents leaving that node is the statement of KCL. So, according to Kirchhoff's current law, right? So, I1 plus I2 plus I3 equal to 0. I1 plus I2 plus I3 equal to 0. The reason is here there is no entering currents. In the circuit diagram, there is no entering currents. My assumption is all currents are leaving. There is no entering current. That's why sum of all the leaving currents equal to 0. So I1 plus I2 plus I3 equal to 0. Right? Now here. Now very, very important step. So observe carefully, all of you. My dear students, observe carefully. Very, very important step here. Now here. So how many paths are there? 3 paths are there. Right? Let us consider first path. Why I consider first path? Now I have to calculate current passing through first path. That means current passing through this. That is I1. I have to calculate I1 value. I have to calculate I1 value. So for that I consider this branch. This branch. I consider this path. Okay. Now from this path, from that branch, I have to calculate I1. Okay. Now see. So I'll explain clearly. Please observe carefully, my students. Now here, let us consider that branch. So I'll consider here. So 3 ohm resistance. Next, 25 volts source. 25 volt source, right? So here V2, of course, that should be 0. Or Vt equal to 0. Here Vt equal to 0. Right? Now, here V1. Here node voltage is V1. Here I have assigned V1 as the variable. Okay, sure, this one is 3 ohm resistor. This is 3 ohm resistor. And this one is 25 volt source. This is 25 volts. I consider first branch of the given network. 25 volt source. Right? Now here, what is current direction here? What is my assumption? Towards this. That is my I1. So current passing through this branch is I1. Okay. Now here, I'll explain clearly. Please observe, my dear friends. Let us assume, let us mark the polarity at this node. So what is the polarity according to current direction? This is my polarity. The reason is, for example, see, here plus minus is there, some voltage source is there, for example, like this. So what is the current flow here? If voltage is like, if voltage source is like this, polarity is like this. What is the current flow here? Like this is the current flow. Okay, now if polarity is like this, if voltage source polarity is like this, voltage source polarity is like this, right? Then what is the current flow here? Current flow is like this. Current flow is like this, right? So according to that convention, now here I assume I marked these polarity as like this. This is minus. This is plus at node V1, at node 1. Okay. Now, simple. Now apply KVL. Now apply KVL. Apply KVL to the first branch. So apply KVL here. See, now according to this current direction, what is KVL here? Minus V1. The reason is here current enters first negative terminal, right? At node V1. Minus V1 plus, now current enters 3 ohm resistor. Now here plus 3 into I1 plus 3 into I1. See, this procedure is common for any type of problem. 3 into I1. 3 into I1, right. Next, current enters positive terminal of 25 volt source. That's why here plus 25 volts plus 25 volts. Of course, here no need to consider this. The reason is voltage is 0. So that should be, this equation should be equal to 0. Simple. Now from this, what is I1 here? From this I1 equal to I1 equal to V1 minus I1 equal to V1 minus 25 by 3. V1 minus 25 by 3. Simple. I1 equal to V1 minus 25 by 3. So this is the explanation. Okay. For calculating the value of I1. So no need to calculate all these things in your examination. Simply you have to write C. So at this node, I have to write equation, write node equation at this node, that is node 1. Okay. So at this node I have to write node equation, right? That means here, so I1 equal to simply V1 minus 25 by 3. Okay. So please assume here, if you want to write first node equation, that is V1 equation, this one equation, node 1 equation, right? So assume that node equation or assume that node voltage is more than any other node equations. Okay, in some networks, some networks, like two or four nodes are there. 2 or 3, 4 number of nodes are more. But here I consider only 2 nodes. Simple network I consider. But in some problems, 3 or 4 nodes are there. In that case, right, we will have to write 2 node equations. Here I have to write only 1 node equation. In some problems, we'll have to write 2 node equations, right? So that time, if you want to write first node equation, then that node voltage is more than any other node equations. If you want to write second node equation and assume that node voltage is more than any other node equation, that is the meaning. Okay, here only one node is there. Now assume this node voltage, that means V1 is more than any other node voltage. That is my assumption. Of course, practically it is not, it may not correct. But here my assumption is that node voltage is more than any other voltage. It's simple. That's why here I1 equal to, right? So here I1 equal to V1 minus 25 by 3. Simple. The reason is here I equal to V by R, basic expression. Voltage means here, now we need to consider voltage across this branch. Voltage across this branch only. So in this branch, how many voltages are there? 2 voltages are there. Of course, don't need to consider VT equal to 0. Okay, only 2 voltages are there. V1 and 25. Take a subtraction of those two. Okay, so that is the logic here. V1 minus 25 by 3. For example, in some cases, here positive is there. In some cases, for example, here like this. Polarity is like this, for example. Okay, polarity is like this. Here 3 ohm resistor is there. This is the node voltage V1. Node voltage V1. This one is that node voltage V1 with respect to ground. This is VT equal to 0. VT equal to 0. So in this case, what is your I1 here? What is our I1? See, in the given network, polarity is different. Now in this network, observe carefully, here I1. I have to calculate I1 value in this branch. Now V1, I1 equal to V1. Here minus is there. Take opposite sign of that. V1 plus 25 by 3. Simple. V1 plus 25 by 3. V1 plus 25 by 3. That is our I1 value. Okay. But here plus minus is there. Here plus minus is there. That's why V1 minus 25 by V1 minus 25 by 3 here. Simple. Okay. So let us consider next branch. Let us consider next branch. Now I have to calculate I2 value, current passing through 5 ohm resistor. I have to calculate that, right? So here now consider this branch. Okay, consider this branch, 5 ohm resistance branch, in this branch. So in this branch only one element is there, that is only one voltage source is there. That's why I2 equal to basic expression V by R. So I2 equal to V1 by 5. Simple. That's why V1 by 5 here. Next consider third branch, this branch. In this branch also only one voltage is there, that is V1. Of course, no need to consider that VT equal to 0. Okay, here also V1 divided by, now these two are content series, 2 plus 1, 3. That's why V1 by 3. Simple, right? So from this equation, we have to calculate V1 value. From this equation, from this KCL equation, we have to calculate V1 value, right? After once V1 is obtained, then we have to substitute that V1 in I2 expression. That is I2 equal to V1 by 5. So from that, we'll get I2 value. That is current passing through 5 ohm resistor. Okay, I'll show you those details. Now see here. See, here V1 minus 25 by 3, that is the first branch current. V1 by 5, second branch current. V1 by, see, V1 by 3. Okay, so from this we get this value V1 equal 9.6 volts. Once V1 is obtained, then current passing through 5 ohm resistor is, basic expression is V1 by V by R. So V1 by 5, right? So 9.6 by 5. So current passing through 5 ohm resistor is 1.92 amperes, right? So with this topic, I learned my session, right? So if you people have